Hello, and welcome to another edition of Mr. Chappell's Chemistry Screencasts. Today we're going to learn about drawing Lewis dot diagrams for ionic compounds. What you'll learn today is how to draw Lewis dot diagrams for ionic compounds. Now, there's only one thing you're going to need to do this: a periodic table. Let's go ahead and get started. Okay, here is a set of problems. Now we're being asked to draw acceptable Lewis dot diagrams for the following pairs of elements, and we're also asked to show the transfer of electrons. So our first one is pretty easy. We have lithium, and we have chlorine, and if you look on the periodic table, lithium has exactly one valence electron, and chlorine has a total of 7. So lithium, being the metal, is going to give his one valence electron to chlorine, just like so. And that's going to give chlorine a complete octet. And so when we're all done, we have lithium, which has lost one electron, so it now has a positive one charge, and chlorine with a complete octet, now with a negative one charge, because it has gained an electron. And this would be your final answer. For our next one, we've got sodium and sulfur, and the Lewis dot for sodium with one valence electron, something like this, and sulfur has got a total of 6. And now we've got a problem, because if we transfer the electron from sodium to sulfur, we can do that very easily, but the sulfur needs another electron. It needs 2 electrons to complete its octet. So pretty clearly what we need to do is we need to add another sodium. And it's going to transfer over its electron, just like so. And the final product is going to be 2 sodiums, each with a positive one charge, and 1 sulfur, now with a complete octet. And of course a negative 2 charge, because it's picked up 2 electrons. And this would be our acceptable Lewis dot diagram for this pair of elements. For the next one, we have the opposite problem. We've got calcium, who has 2 valence electrons, and we have fluorine, who needs just 1 electron to complete its octet. And although that makes the fluorine happy, the calcium still has 1 valence electron that it needs to get rid of to lose its valence shell, so we're going to need to add another fluorine. And let's go ahead and transfer that second electron over to the other fluorine, and there everyone is happy. And when we're done, we have calcium now with a positive 2 charge, and we've got 2 fluorines, and the fluorine has an octet, and each of them has a negative 1 charge. And this would be our final answer. Okay, I saved the best for last. Here we have Mr. Magnesium and nitrogen. And magnesium, of course, has 2 valence electrons, and nitrogen has a total of 5 valence electrons. And let's go ahead and transfer the 2 electrons that the magnesium has. Okay, and you can see that makes that magnesium happy, but the nitrogen still needs another electron to complete its octet. So let's just go ahead and add another magnesium. And let's go ahead and transfer that electron over. Okay, so that makes that nitrogen, excuse me, happy with 8 electrons. But now we've got the magnesium, who now has an extra electron. So what we're going to need to do is we're going to need to add another nitrogen with a total of 5 electrons. And that 1 electron from the magnesium gets transferred over. And well, now we've got the nitrogen needing 2 electrons, but fortunately, if I just add 1 more magnesium, I can get both of those electrons to transfer over. And there, we're done. Oops, those should have been black, but I'm just going to go ahead and leave that. And when we're finally finished, we get 2 magnesiums, each with a +2 charge. And whoops, let's undo that and let's do that correctly. We get a total of 3 magnesiums, each with a +2 charge. And we get a total of 2 nitrogens, each with an octet, and they've gained 3 electrons. So their charge is -3, and that's how you do it. And that's our final answer. And that concludes this lesson. Okay, it's joke time once again. So this jumper cable walks into a bar and says to the bartender, "Hey, can I order a drink?" And the bartender says, "Sure, but don't start anything."